Hey everyone, and welcome to Today's Explainer. I am so incredibly pumped you're here because we are diving headfirst into one of the most explosive, fast-moving tech evolutions of our entire lifetime. We're talking about the unstoppable rise of future robotics and the smart factory. If you've been sitting there wondering what this massive leap in technology actually means for the factory floor, for global industries, and yeah, for your own career, well, you're in the exact right place. Let's get into it.
So let's just address the elephant in the room right off the bat, right? The big question. Will AI and these next-gen robots completely wipe out human jobs, or are they going to transform them into something totally different? Look, whenever we talk about automation, there's always this mix of genuine curiosity and, let's be honest, a fair bit of anxiety. But today, we're going to unpack the actual reality of how artificial intelligence and advanced robotics are teaming up with humans to change the way we work forever.
Okay, here's our game plan for today's explainer. We'll start with an intro to future robotics, look at the key components, check out the different types of smart robots, dive into Industry 4.0 and AI, weigh the benefits and challenges, and finally, take a look at DVI automation solutions.
All right, Section 1, an intro to future robotics. There is just this wild, stark contrast between where we are right now and where we're rapidly heading. Present-day robotics, they're basically heavy lifters locked in a cage. They're pre-programmed to do these highly repetitive tasks, completely isolated just to keep human workers safe. But future robotics, they break totally out of that cage. Powered by AI, they're driven by real-time data, they're highly adaptable, and honestly, most importantly, they are collaborative. They aren't just blindly running a code loop, they're actually perceiving the world around them and adjusting on the fly.
Moving right along to Section 2, the key components.
For all the electricians and automation engineers tuning in, the absolute easiest way to wrap your head around the anatomy of a smart robot is to just compare it to the human body. The sensors and cameras, those are the eyes, constantly pulling in visual data. The AI processor is the brain, making sense of all that input. The physical robotic arm and the servo motors act as the muscles, doing the actual heavy lifting. And tying the whole shebang together, the PLC, HMI, and SCADA systems, that is the central nervous system, firing off signals and commands at lightning speed.
Now, I really want to highlight one specific term here because it's absolutely crucial, the end effector. Basically, think of this as the robot's hand. What makes future end effectors so next level is that they are packed with super sensitive force and torque sensors. This literally gives a massive industrial machine a delicate, human-like sense of touch. So that robotic arm knows exactly how much pressure to apply to pick up an egg without cracking it, or how to perfectly tighten a bolt without stripping the threads. It's amazing.
And obviously, to make sure that brain and those hands are flawlessly in sync with the rest of the factory floor, we rely on IIoT connectivity. The Industrial Internet of Things is the master communication link. It's this invisible web that ties the robot controller, the PLC, the SCADA systems, and cloud analytics all together into one seamless network. It literally lets the machines talk to each other and share real-world data in real time.
All right, let's hit Section 3, types of smart robots.
The lineup out there today is incredible. We've got collaborative robots, or Cobots, which are built specifically to safely share a physical workspace with humans. You've got autonomous mobile robots, AMRs, just roaming around navigating massive logistics warehouses totally on their own. We're even seeing humanoid robots now. Plus, hyper-precise medical and surgical bots assisting in operating rooms, and agricultural robots actively monitoring crop health out in the fields. The use cases have expanded way beyond just standard manufacturing. Up next, Section 4. Industry 4.0 and AI. You guys, this right here is the magic formula of the next industrial revolution. When you take artificial intelligence, combine it with machine vision, which is, driven by deep learning and computer vision, and you link all of that up via cloud robotics, boom, you get the smart factory. This is an ecosystem where machines don't just wait around for human orders. They actually see, they learn, they optimize their own workflows, and they make autonomous decisions. And the real-world applications of this formula, they are staggering. This tech is completely revolutionizing automobile and electronics manufacturing with pinpoint precision. It's completely transforming warehouses and logistics. I mean, we're talking everything from ensuring flawless hygiene in food processing and pharmaceuticals to handling insanely dangerous jobs in construction and even space research. The smart factory isn't some distant sci-fi concept. It is already here. Section 5. Let's weigh the benefits and the challenges. Okay, so objectively, the benefits are totally undeniable. You get a massive spike in production and laser-like precision. You get 24/7 operations, way fewer errors, and you get humans out of the most dangerous, high-risk tasks. But we have to be real here. The challenges are serious. The initial investment cost to set all this up, it is steep. And by connecting your entire factory to the cloud, you are absolutely opening the door to major cybersecurity risks. Not to mention the programming complexity to actually keep this stuff running smoothly requires a highly specialized skill set.
Which brings us right back to that elephant in the room, our careers. The key takeaway you need to hear is this. Human jobs are not disappearing, they are evolving. We are shifting away from that dangerous, repetitive manual labor and stepping into roles that demand AI, robotics, and automation expertise. Upskilling is literally the name of the game right now. Learning how to program, maintain, and manage these advanced systems, that is exactly where the future of the workforce is going.
And that brings us to Section 6, DEVI Automation Solutions.
So if you're wondering how industries actually pull this off, DEVI Automation Solutions is sitting perfectly at the intersection of everything we just talked about. They offer this incredibly comprehensive suite of expert services covering industrial automation, PLC, HMI, SCADA, VFD, AI, and IoT integrations. But what's cool is they don't even stop at the factory floor. They also do smart agriculture, home automation, and solar solutions. If you need to take these massive, high-level concepts and turn them into practical, everyday operations, they are an amazing resource. So whether you are an ITI student, a diploma holder, an engineer, or a facility manager who knows it's time to upgrade your systems, definitely reach out to them at diaautomationsolutions@gmail.com. And hey, if you found this explainer valuable, please smash that like button, share it with your coworkers, and subscribe for more deep dives. Also, jump into the comments below and let me know, what specific automation, robotics, or AI topic do you want us to tackle next?
I want to wrap up today with a thought that I think puts all of this into perspective. Robots are not here to replace us, they are here to elevate human potential and build the smart factories of tomorrow. Remember, we are the ones who design them, we program them, and we're going to work alongside them. The future of engineering is incredibly collaborative and it's full of opportunity. So my final question to you is, what steps are you going to take today to prepare for your new robotic colleagues tomorrow? Thanks for hanging out with me on this explainer. Stay curious, and I'll catch you in the next one.